Hey, so here's the solutions for the free response from April 29th, and we're looking at problems where they give you a graph and ask questions about it like this. For part A, they're asking to find the average rate of change from G where G is the integral from 1 to x of f of t, this guy, from x equals -5 to 5. So the way I started with this one is I said, okay, well, the average rate of change of G would be G of 5 minus G of -5 over 5 minus -5. And this is how a lot of you started. Now, G of 5 is here, the integral of 1 to 5. So it's the area there, which would equal this rectangle, which is 2 by 4, so that's 8, plus this triangle, which is 2 by 4, which is 4. And then from x is -5 to 5, we're going backwards. So that's 1 to -5 all the way down here. Now, the nice thing is, since we're going backwards, these become positive. So then, though it's below the x-axis, because we're going this direction, the sign switches. So we've got that first little triangle right here, which has an area of 1, and then a quarter circle with radius 2. So that's 1/4 pi times 2 squared. And then finally this last triangle, which is 3 by 4. So it has an area of 6. And then all over 5 minus -5, which is 10. Since this is no calculator, we're going to do a little bit of simplifying, and we're going to leave pi as is over here. So we've got then 12 minus 7 minus pi all over 10, which gives us 5 minus pi over 10, which would have been just fine to leave like this. A lot of you rewrote it who got this problem right as 1/2 minus pi over 10, which either one of these would have been just fine. All right, part B, the instantaneous rate of change of G with respect to x at x equals 3. So instantaneous rate of change, remember, is the derivative. So this is asking for the derivative of G at 3. Well, if you remember the derivative of G using the fundamental theorem, if I take the derivative of this side, the derivative and this will cancel out, meaning that we've got f is equal to G prime, and we can see on our graph f of 3, which is right here, would be this point, meaning that it's 4. Looking at part C, on what intervals, if any, is G concave up? Well, if G is concave up, that means that G prime, double prime, has to be greater than 0. That means that if we're looking at the graph F, that means that F prime has to be greater than 0, since these two are basically synonymous. And so from there, what that means is here is that F has a positive slope. And the way that you translate this logic into your justification is up to you. Just remember to do a complete sentence. Where we're looking where it's positive, we've got this section here where F is positive, has a positive slope, and this here. And so then you'd write your final answers if you want to use the interval of -5 and x to -3, and then 0 to +3. Oh, not -3, -2. I can count. So those are the two intervals that we're looking at for our concavity. Lastly, for part D, It's asking where G has a critical point, and so that's asking where G prime is equal to 0. So as we've discussed before, that's the same as saying where F is equal to 0. Or if you want to consider D and E, the AP, for some reason, doesn't consider those points D and E. Those of you who did, fabulous. But we're looking at these two places here. If you want to look here and here as well, I think that's great. Where it equals 0, we can see here that this is happening at -2 and 1, which gets you the majority of those points. You get one last point for asking if it's a maximum, a minimum, or neither. So at -2, it's neither because it's got a negative and then negative. So if we're looking at, here's G prime, it's 0 here, and then negative and negative on both sides at x equals -2. And then at +1, we're still negative, but then on the other side it's positive. And so then this is a minimum, and this is neither. And again, since you're justifying your answers, how you write the complete sentence is up to you. Hopefully this was helpful. Please jump on, ask any questions that you have on Google Classroom by email or Zoom.